Okay, listen. So in last class, now it is visible, right? Okay, in the last class, we were discussing about the different feedback amplifier, and in that feedback amplifier, so we have calculated how the feedback, each type of feedback amplifier, whether it is a series shunt configuration or shunt series configuration, or series or series shunt. So all the four different types I told you to. Okay, so this is first the series shunt feedback amplifier, and here you can see the input and output, how the, what is the type of the signal, and based upon that mixing as well as how we need to take the sampling of the signal I have told. And based upon the four different feedback amplifiers circuits, so all the feedback amplifiers, all the feedback normally with amplifier with the feedback circuit, so it will be called as feedback amplifier. So all the feedback amplifiers will be able to control the input and output resistance. So on employing a negative feedback for different amplifiers, whether it is a voltage amplifier or current amplifier or transconductance amplifier or it is a trans resistance amplifier. So whenever we employ a feedback circuit, how it is going to control the input and output resistance we have seen. So first, by employing the feedback circuit for the series shunt, we have seen how on employing this feedback circuit, the input resistance with feedback when compared to the input resistance of the amplifier, if we compare, so it has been increased by a factor of 1 plus A beta. So that is what we have seen. That means on employing this circuit, it is going to increase the input resistance of the feedback amplifier. So that is what we have come to the conclusion. At the same time, since the output is of shunt type, so when we calculated the output impedance or output resistance, so we have come across that the output resistance of the amplifier proper is given by R0. But when you employ a feedback circuit, the output resistance of the entire circuit is going to be get reduced by a factor of 1 plus A beta. So R0 is nothing but the output resistance andre. So when you calculate for the ROF, that is the output resistance, when you employ feedback, so the ROF will be equal to R0 divided by 1 plus A beta. That means the equivalent or the output resistance with feedback, it is going to reduce the output resistance when compared to the without feedback. So without feedback, R0 will be the output resistance. When you employ feedback circuit, the feedback resistance is called as R0 of F. So that is going to be reduced by a factor of 1 plus A beta. So that is for series shunt feedback amplifier. So we have seen, started from the gain expression we started, and then we have derived for what is the input resistance with feedback and output resistance with feedback. So input resistance with feedback, so we have to consider the equivalent circuit of the series shunt. So this is ideal series shunt feedback amplifier. So corresponding equivalent resistance, equivalent circuit can be written like this. This is going to have a gain of AF because it is a feedback gain multiplied with the signal input is Vs. So when I am going to write the equivalent circuit, you have to pay attention. If you don't pay attention here, then obviously the subject is going to be difficult. So this is the input signal Vs and output signal is V0. So we know that the feedback, when you employ the feedback, the gain which we are going to calculate is V0 by Vs. So Vs is the equivalent input signal and V0 is the output signal. So how we are going to call it as the feedback gain? So input is input resistance with feedback and output resistance with feedback, and the gain which you are going to get from this feedback upon employing feedback is feedback gain, negative feedback gain, that I am going to represent as AF. So previously, if feedback circuit was not there, so here you can see the circuit of the amplifier is going to have input resistance Ri, R0 as output resistance. The gain of the amplifier is denoted as A times of Vi. So this is without feedback, because we have assumed that this feedback circuit beta is not going to load on the amplifier, and this is the amplifier circuit. But now when you employ this feedback, the entire thing of the circuit is going to be now feedback amplifier, not just an amplifier, it is feedback amplifier. What type of feedback? It is negative feedback. So when you employ negative feedback, entire circuit I can write it as Vs is the input signal, because these two together combined, so this is the Vs is the input signal, and here whatever the resistance is there, so whatever the resistance here feedback is having, so together you will be having input resistance with feedback, and here whatever the output resistance with the feedback and the amplifier we are going to calculate as R0 of F, that is output resistance with feedback. And here, since on employing the feedback circuit the gain is going to be modified, that gain is called as closed loop gain, or it is also called as negative feedback gain. It is denoted as AF times of Vs. So whatever the input signal Vs is given, it is going to amplify by a factor of AF because of negative feedback, and this is what ROF and RIF. Now for us important is we know already what is gain. Correct? Our general feedback structurally we have obtained the gain expression, so AF is known. What is Vs signal we know. So only thing RIF and ROF we need to find in this series shunt. So we are going to calculate, establish the relation, and we are going to find out what is input resistance with feedback. And also I have told for your easy to understand or easy to remember, so whenever the configuration is being given, so in the configuration ಅಲ್ಲಿ series shunt ಅಂತ ಇತ್ತು ಅಂದ್ರೆ, so you have to think series means the resistance is going to increase by a factor of 1 plus A beta. So it is whether it is an input side or output side, you have to check and you have to see. So without any putting more efforts, you can assume if it is in series means input side the resistance, because we are going to use this to calculate the input resistance with feedback and output resistance with feedback, because upon employing the feedback circuit, how it is varying or how it is controlling the input side and output side, we are going to vary for 4 different feedback amplifier configuration. For 4 feedback amplifier, the signals at the input side and output side are varying. So because the input and output side signals are varying, so the input resistance or impedance or output resistance or output impedance is also going to vary. So for that we are going to find out how it is varying. 5 properties of negative feedback, really 4 properties already you are familiar with the negative feedback. So that means when you employ negative feedback, how it is reducing noise distortion, how it is reducing nonlinear distortion, how it is extending the bandwidth, how it is going to desensitizing the gain. 4 property kaltagide. So another 5th property is how on employing negative feedback it is controlling the input and output impedance. That is what we are going to derive over here. So for that 4 different configurations are there. So each how the feedback, negative feedback is controlling the input side and output side impedance we are going to calculate. So series at the input side means you will be getting the input resistance, so we are going to increase by a factor of 1 plus I beta, 1 plus A beta. So this is what the input resistance with feedback which we have already derived. Correct? The last day, the day before yesterday I have done this derivation, right? So input resistance with feedback we have calculated. So input resistance with feedback is going to increase the input resistance by a factor of 1 plus A beta, since it is in series configuration at the input side. The same way, to calculate the output resistance, I have told, whenever you want to calculate the output resistance, so we need to make the signal source Vs to 0 and apply a test source across the output side. So depending upon whether it is output is current or voltage, if it is a voltage means voltage test signal you have to apply. If it is a current means current test signal you have to apply at the output. Whether you are able to understand, to calculate the output resistance, first step is make signal source to 0 and apply a test source across the output side. So output side, depending upon the type of the signal, current agidre, current test current source apply madbeko, voltage agidre, so voltage test voltage source you have to apply. Since the source signal is 0, only part is through the feedback part because of the applied test circuit source. So you will be seeing and you are going to find out what is the output resistance with feedback in the shunt configuration. That is, in this case, shunt is the output side. So that is ROF. So here if you find, since it is a shunt, I have told you have to get the output final expression should be R0 by 1 plus A beta. That means in the output side, the resistance, output resistance is reduced by a factor by 1 plus A beta. Without feedback, it is R0. With feedback, it is R0 divided by 1 plus A beta. So this thing you should remember. So the same thing you have to consider for series. So in the series part, so you can see series across the input side and series across the output side. So the voltage, the input side is voltage signal and the output side it is current signal. So that corresponding amplifier we are going to call it as transconductance amplifier, and for that transconductance amplifier the ideal circuit it has been written like this. So you can see the output side, that is current signal. So I0 is the current signal and you can see that it is connected, that is sampling of the current is going to take place in series way. So you can see that the output signal is current signal. So what is input side? Input side is a mixing type, so it is of series type. So series type mixing is happening only for voltage type signal. So you are going to have voltage signal as the output of the feedback. And input side it is mixing means it is going to add with the series, that is a signal source voltage plus feedback voltage is going to add in series. So input is voltage, output is current, so the amplifier is transconductance amplifier. And now coming to the part equivalent here is not written I think. So okay, here also they have written equivalent amplifier, transconductance amplifier with feedback. Here equivalent circuit of the series feedback you have to write. So when you write the series feedback, so again you can see the gain which you are going to get is AF. For any type of amplifier I have written on the board on the first day itself. Negative feedback means whether any different 4 different types of amplifier, negative gain is going to remain constant. What is the negative feedback gain? Negative feedback gain AF, what is A over 1 plus A beta. So that is going to remain constant irrespective of the feedback amplifier circuit is concerned. Whether it is a voltage amplifier or current amplifier, transconductance or transresistance, feedback, that is gain with negative feedback, is going to remain constant, that is equal to A over 1 plus A beta. So since the output is of current, so we are going to make it equivalent current source, equivalent gain we are going to make. So here whatever the input is voltage type, so I am going to apply Vs as the input side through the input resistance with feedback. So it is going to have amplified version. So amplified version will be AF times of Vs should be there, but here AF times of Vs only it is there, but since the output is of transconductance, output should be in current, so I am going to make it an equivalent current source with a parallel combination of the ROF. Artha agta idea? So if it is a voltage means I would have written AF times of Vs and series with the ROF. Since it is the output is of current type, so I am going to connect the ROF in parallel. So this is what the equivalent series feedback. So now again you can see, since the input side is of series type, so the same calculation we have done for this type of amplifier, right? So here also it is series type only. Series shunt configuration only. The input side was series. So again, here also the same equation, the derivation can be continued here, because the same thing you are going to repeat over here in the case of series, because the voltage is adding in series with the feedback signal. So the same equation can be holds good. Whereas the output side, it is series. So series input aaytu andre enagutte. So what is the input resistance with feedback? Without anything, what you should tell? Input resistance with feedback will be equal to Ri multiply with 1 plus A beta. So that means input resistance is going to increase by a factor of 1 plus A beta. The same thing you can see RIF for the series configuration. RIF again will be having Ri into 1 plus A beta. Correct? Artha agta idea? So next is what? In the previous case, series shunt was there. At the output side, shunt it was. Now series. So we have to calculate R naught of F. So R naught of F, in order to find out the R naught of F, so we have to, again, what I should do? Make the signal voltage as 0 and then connect a test current source, because the output is of current type. So we have to connect on test current source. The same thing here I have written test current source. Why current source at the hey, yeah, see, ನಾನು ಇದು ರಿವಿಷನ್ ಮಾಡಬೇಕಾಗಿಲ್ಲ, ಅವತ್ತು ಮಾಡಿದ್ದೆ ತಾನೆ. ಇದು 2 hours ಕಂಟಿನ್ಯೂಸ್ ಆಯಿತು ಟೇಕನ್ ಅಂಡ್ ಡ್ರಿಡ್. ನೀವು ತಲೆಗೆ ತಗ್ಸ್ಕೊಂಡು ಕೂತ್ಕೊಂಡ್ರೆ, ಸೊ ವಾಟ್ ಈಸ್ ದ ಮೀನಿಂಗ್? ನಾನು ಯಾರಿಗೆ ಪಾಠ ಮಾಡ್ತಾರೆ ಇದು? ರೂಮ್ ನನಗೆ ರಿವಿಷನ್, ನನಗೆ ಬೇಕಾ ರಿವಿಷನ್? ಬುಕ್ಕಲ್ಲಿ ಬರೀತೀರಾ ಹೋಗ್ಲಿ? ಇಷ್ಟೊಂದು ಐ ವಿಲ್ ಬಿ ಗಿವಿಂಗ್ ದಿಸ್ ಮನಿ ಫೀಡ್ಬ್ಯಾಕ್, ರೈಟ್? ಸೊ ಇಷ್ಟೊಂದು ಕೊಡ್ತೀನಲ್ಲ. ಸೊ ಹ್ಯಾವ್ ಯು ರೈಟ್ ಎನಿಥಿಂಗ್ ಆನ್ ದ ಬ್ಲೂ ಬುಕ್ಸ್? ಇಂಪಾರ್ಟೆಂಟ್ ಟಿಪ್ಸ್ ಏನಾರ ಹೇಳ್ತಾ ಇದ್ದೀನಿ ಅಂದ್ರೆ ಯು ಶುಡ್ ನೋಟ್ ಡೌನ್. ಸೊ ಸೀರೀಸ್ ಅಂತ ಹೆಂಗ್ ನೆನ್ಪಿಟ್ಕೊಬೇಕು? ಸೊ ಐ ಆಮ್ ಗಿವಿಂಗ್ ದ ಟಿಪ್ಸ್ ಆಲ್ಸೋ. ಅದು ಒಂದನ್ನು ಕಲ್ತ್ಕೊಂಡ್ರೆ ಸಾಕು. ಆಲ್ 4 ಡಿಫರೆಂಟ್ ಕಾನ್ಫಿಗರೇಷನ್, ಎನಿ ಟೈಪ್, ಓನ್ಲಿ ದ ಸರ್ಕ್ಯೂಟ್ is going to vary, equation derivation will be remain constant. ಅದನ್ನು ಹೇಳಿದ್ದೀನಿ. ಸೀರೀಸ್ ಶಂಟ್ ಅದರ ಇತ್ತಂದ್ರೆ ಹೌ ವಿ ಶುಡ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ವೆದರ್ ಇಟ್ಸ್ ಅ ವೋಲ್ಟೇಜ್ ಆರ್ ಕರೆಂಟ್, ಹೌ ವಿ ಕ್ಯಾನ್ ವೆರಿಫೈ ಅಂತಾನು ಹೇಳಿದ್ದೀನಿ ಅವತ್ತಿನ ದಿವಸ. See, who will give apart from this? ಇನ್ನು ಏನು ಎಕ್ಸ್ಪೆಕ್ಟೇಷನ್ ಇದೆ ನಿಮಗೆ ಫ್ಯಾಕಲ್ಟಿಯಿಂದ? ಇನ್ನು ಎಷ್ಟು ಸಿಂಪಲ್ ಮಾಡ್ಬೋದು? So here the output is current signal. So I am replacing the output with the current test current source, and here also you will be having that current is flowing here. So you are going to apply. So SS dash I am making it as 0. So that means I am going to connect a short circuit so that there are signal source voltage is 0. And since it is series, again you will be getting the expression R naught of F will be equal to R naught multiply with 1 plus A beta. So do not get confused. What is the output? When you are going to calculate output resistance, you have to write in terms of R naught only. R naught multiplied by 1 plus A beta, and Ri multiplied with 1 plus A beta. So compared to series shunt configuration, series configuration only, you can see out when you employ for the series configuration, input resistance with feedback is increased by a factor of 1 plus A beta. At the same time, output resistance is also increased by a factor of 1 plus A beta. So if these two configuration, if you know remaining two, shunt, series, shunt, you can derive by the same expression. The same way you can do it for the remaining two configuration. So shunt series. Shunt andre what is the input resistance? Equivalent Ri divided by 1 plus A beta ಆಗಿರುತ್ತೆ. Shunt output is also shunt ಆಯ್ತು ಅಂದ್ರೆ R naught divided by 1 plus A beta ಆಗಿರುತ್ತೆ. So input resistance with feedback and output resistance with feedback will be reduced by a factor of 1 plus A beta in shunt configuration. Shunt series ಆಯ್ತು ಅಂದ್ರೆ ಏನಾಗುತ್ತೆ? Shunt at the input side ಆಯ್ತು ಅಂದ್ರೆ Ri divided by 1 plus A beta ಬರುತ್ತೆ. R naught into 1 plus A beta ಆಗುತ್ತೆ, because shunt series configuration. Ulta of this, series shunt series. So shunt across the input andre reduced by input resistance will be reduced, output resistance will be increased. This is what you have to learn. Idana topic madake 2 hours whatever I took on the last class, so that is sufficient. Now some of them, most of them students were absent on that day 15th, right? So today is 18th, so 15 most of them were absent. 16th you were absent, so I am doing again andre in detail madakagala, so I am refreshing so that you can understand anta, so you should not forget. So if this is completed, so first half of the third module aram se you can score. Second half of the first question, so 10 marks 100% question ಇದರಲ್ಲಿ ಯಾವ್ದಾರ ಒಂದು ಬರುತ್ತೆ. ಯಾಕೋ ಟೈಮ್ ಲೇಟ್ ಆಗಿದೆನಾ? Okay, so any doubt is there? Any doubt is there? No. The same way we are going to now the remaining third module second half. So ನೀವು ಇಲ್ಲಿ ತನಕ, that is up to high frequency response, low frequency response and characterizing parameters, and up to the feedback amplifier. If you study properly, then if they shuffle the questions also you can attempt for full 20 marks for the third module. Actually these feedback amplifiers will come for the second half of the third module. Second half only questions barbeku, but if they ask in the first half of the third module also, you can attempt third question for 20 marks without any hesitation. If you feel first half is difficult, second half is very easy. 3 to 4 derivation is there, that is also very easy. Class A, class B, class AB, class C amplifier. You nalakunu how the power amplifier is going to work. If you learn this 4 derivation, then third module is not at all difficult. Artha agta idya? So class power amplifiers kaltidira, so have you learned in the basic? No. What is power amplifier? So what is power? Power means what? According to general knowledge, power will be equal to how the expression for the power is given. P is equal to VI. So till now what we were dealing, so in the second module and all we were dealing with only 2 signals, right? Current and voltage. But now we are going to learn for the next stage is power amplifier. That means whenever we are going to deal with the small signals, current and voltage signal which are of very small magnitude, we are going to consider the small signal amplifier. But now here we are going to learn about large signal amplifier. Typically it will be kept at the output stage. So you can see that speaker and all, the speakers, microphone, so and all, so television, radio and all, so you can see the speakers. So where the signal which we are dealing in the speakers and all is power signal, so we are going to call it as power amplifier. So that power amplifier will be working with respect to V and I both, not only single. Suppose if it is a single stage amplifier, voltage will be given as an input signal, voltage will be amplified. Current will be given, current will be amplified. Voltage will be given, or you will be getting current as the output. Current will be given, current will be the output. Like that, we will be dealing only with respect to V and I in the previous case. Now we are going to deal with both voltage and current to give an output stage which is nothing but a power amplifier. So product of V and I, that is nothing but a power signal. So in this power signal, power amplifiers, we are going to learn. So basically for each of the amplifiers, so we are going to have different output stages are there. For each of the different output stage, how the power amplifier or the signal it is going to work, we are going to learn. In this mainly we are going to learn about how much is the supply power, how much is the power dissipated, what is the maximum power conversion efficiency. So these three things mainly we are going to deal. So we are going to deal with what is the supply power and what is the power dissipation in each of the output stage, and what is the maximum efficiency for each of the output stage of the amplifier. So in this output stage of the amplifier, so we are going to classify into 4 different stages. Okay, class A amplifier, class B amplifier, class AB amplifier, and class C amplifier. So these are the 4 output stage. So output stage andre ಏನು? Output stage of the amplifier. So that means it will be dealing with the last signal. So now if you consider op amp, if you consider the op amp, you will be having so power amplifier so you understand what is op amp. Okay, operational amplifier if you consider, so it will be having input stage. Input stage will be there, intermediate stages will be there, and finally the output stage will be there. So the internal structure of the op amp if you consider, so it will be, because it is giving high gain. So input, if it is microvolt change between the two input terminals, ಎರಡು input terminals ಮಧ್ಯದಲ್ಲಿ, if it is small microvolt, typically 5 microvolt difference idrunu the gain will be getting is more. So it will be in terms of 10 power 6 without any feedback. That means from output to input if you consider, so the gain is going to reduce. But if it is an open loop amplifier, so if you give the input, the gain will be getting in terms of 10 power 6, 10 power 7. Microvolt input will be amplified at the output stage. So ಇಷ್ಟೊಂದು ಔಟ್ಪುಟ್ ಅಲ್ಲಿ ಗೇನ್ ಬರಬೇಕು ಅಂದ್ರೆ, so what is the structure of the intermediate stage? So intermediate stage ಅಲ್ಲಿ ಏನಿರುತ್ತೆ, so you will be having input stage as differential amplifier. So input stage will be having differential amplifier means non-inverting input irutte, inverting input irutte. So it is nothing but a differential amplifier. So the name itself differential amplifier is what? So difference between the two input. So difference between the non-inverting and inverting will be given as output over here. Okay, the first stage of the output will be equal to V in 1 minus V in 2. So this difference will be getting across the output of here. So here it is non-inverting, because if you don't connect here anything, so if you give any signal over here, so the same type of signal will be getting across here. So the output and input if you consider, both will be in phase, hence it is non-inverting. Whereas if you consider the input when you apply over here, so it is made equal to 0. So that means non-inverting input if I am making it as 0, and only I am applying input to this terminal. So the output if you are going to get here is inverting type. Hence the name is being given as inverting input. Any input if I apply here, the output if you consider, both will be in 180 degree out of phase. So here what I am getting, difference between these two. Suppose here is 3 volts, 2 volts, then I will be getting here as what? 1 volt as the output. For this output voltage to convert into 10 power 6, 1 into 10 power 6. how much I should add. Intermediate stage. So intermediate gain stage will be there. So many intermediate gain. It can be common source or it can be common emitter, like that, because emitter, common emitter as well as common source are the basic single stage amplifiers which we have analyzed thoroughly. So the same thing when it is cascaded, as I told, it will be having multiple stage. Single stage only will be not getting 10 power 6 gain. So the output of this will be given to first stage. The output of the first stage will be given as input to the second stage. And output of second, again it will be amplified to the third stage. Third stage again amplifies the input to the fourth stage. Like that, intermediate stage gain is going to be there. So after that, it will be given to the final output. So that is the nothing but the output stage of the amplifier, which we are now dealing with the output stage. So this output stage will be dealing with the large signal as input. So here you can see the small signal difference will be coming over here, but as it passes through the intermediate stage, the signal amplitude is going to increase in large, wherein which it is going to have the output stage is going to deal with the large signal. So large signal will be acting as an input, and how the output we are going to get. So that is to get, you are going to get like that. So large signal bandondre, again the output stage will be getting the output in terms of 10 power 6. The same thing, if I connect one feedback, the gain is going to reduce. Op amp into gain is going to reduce if I employ a negative feedback. So negative feedback is inverting input. If I am connecting the output, so you will be getting the gain will be reduced. You will be not getting the gain by 10 power 6. You will be getting the gain as RF by R1. That is what type of amplifier it will be getting the gain as minus RF by R1? Inverting gain. Suppose the same thing with the two resistance, if I am going to connect here to the inverting input, we will be getting as the gain as what? R1 plus that means 1 plus R1 by RF, that is non-inverting gain. So this is also reducing the gain when compared to the open loop gain 10 power 6. 10 power 6 as because it is reduced by 1 plus R1 by RF. The same way, if I don't connect anything, so complete output signal if I am going to give, then we will be getting V0 will be equal to VE. This is voltage follower. So output signal, the entire thing, if I am going to connect there, so that is voltage follower. So if I am going to have inverting so RF by R1. So from the output to input, if I am going to have RF by R1, if I am going to have, then this type of gain will be getting as inverting gain. This is voltage follower and this is non-inverting. So these gains are going to be very less when compared to the open loop gain. So that is one of the drawback in the negative feedback. So what is the negative feedback? Even though it makes the desensitizing the gain, but the gain when compared to open loop gain, the closed loop gain will be always less than the open loop gain. Correct? A over 1 plus A into beta. A is nothing but open loop gain multiply with beta, so that is feedback gain. So when you consider the feedback gain, so these are all nothing but the feedback gain only. So feedback gain will be always less than open loop gain by factor of 1 plus A beta. So this is only the one drawback which you are going to find in the case of negative feedback. Apart from that, all are advantage you are having. Bandwidth will be increasing, desensitizing the gain, noise reduction, non-linear distortion will become reduced, and you can able to control the input and output impedance. So these are the important properties of the negative feedback. So at the expense of gain, all advantage you are getting, but you are having the gain value will be reduced. So now today we will see what is the in the module 1, we have used biasing of the amplifier, right? So biasing of the amplifier, in this, can you able to tell what is the current expression IE? What is current? Are IE Gotto? What is current expression I am asking? What type of balancing it is? To become constant, the answer of the question again. Not only this configuration, I am asking about this particular configuration. What is I? This is what type of configuration biasing scheme? Voltage with drain like collector to base feedback resistor. So illenna connect madidina, connect madidandre artha eno? Already I have employed with the output to input negative feedback. So there is no point in employing RE, because the purpose of RE is negative feedback. Here already negative feedback I have employed, because we know any signal which you are applying across the base, and if you are going to collect at the collector, so common emitter will be, so by the transistor output itself you know that it is 180 degree out of phase. So output to input, if I am going to collect, that is nothing but negative feedback itself. So this is IE, something it is there. What is output? So output, you are going to get what is the output expression? VCC correct. So these two things you should remember. In the next class I will tell how the classification of the power amplifiers is being done, because this will be the final output stage. So output stage there is no much difference. There is no symbol difference between power amplifier as well as the normal small signal amplifier. This is, we are going to call it as power BJT. The same thing if I am going to use MOSFET, power MOSFET we are going to call. But symbol, they are going to have the same symbol over here. Only difference is it is going to deal with large signal. The same way, if it is going to deal with small signal, we are going to call it as small signal amplifier. If it is a power signal, then it is going to be called as large signal amplifier or power amplifier. Normally, we are going to use this in the output stage, hence we are going to call it as power output stages or power amplifier in the output stage. Okay, next class. With this, I'll just conclude today's class.